A single nuclear weapon can destroy a city and kill most of its people. Several nuclear explosions over modern cities would kill tens of millions of people. A nuclear blast occurs when a nuclear bomb explodes. It causes destruction over a wide area within seconds to minutes. The health effects depend on the distance from the blast. Injury or death may result from the blast itself or from flying debris. Those who look directly at the blast could experience temporary blindness or severe eye damage. In this video, we're going to discuss dangers of nuclear explosion and how to survive one. The video is going to be amazing, so make sure you stick to the end. People near the blast site would be exposed to high levels of radiation, causing severe skin burns, shock, and death within minutes to days. Nuclear weapons are the most terrifying weapon ever invented. No weapon is more destructive. No weapon causes such unspeakable human suffering, and there is no way to control how far the radioactive fallout will spread or how long the effects will last. When a nuclear weapon explodes, the kinetic energy from the fission fragments, neutrons, and helium for fusion reactions heat the weapon debris to approximately 20 million degrees centigrade, the temperature of the sun, within a few microseconds. This hot core radiates energy like the coals in one's fireplace. However, because the temperature is so high, the radiation is in the X-ray band of the electromagnetic spectrum. As the hot core expands, it begins to cool. The result is a huge sphere of very hot air or fireball that begins to rise, eventually creating the mushroom cloud so often associated with nuclear explosions. All ionizing radiation is carcinogenic, but some tumor types are more readily generated than others. A prevalent type is a leukemia. These radiation exposures can damage living cells, killing some and modifying others. The destruction of a sufficient number of cells will inflict noticeable harm on organs. Nuclear weapons have been tested in all environments since 1945, in the atmosphere, underground, and underwater. Tests have been carried out on board barges, on top of towers, suspended from balloons, on the Earth's surface, more than 600 meters underwater, and over 200 meters underground. Nuclear test bombs have also been dropped by aircraft and fired by rockets up to 320 kilometers into the atmosphere. The cancer incidence among survivors of Hiroshima and Nagasaki is significantly larger than that of the general population, and a significant correlation between exposure level and degree of incidence has been reported for thyroid cancer, breast cancer, lung cancer, and cancer of the salivary gland. Often a decade or more passes before radiation-caused malignancies appear. A 1991 study by the International Physicians for the Prevention of Nuclear War (IPPNW) estimated that the radiation and radioactive materials from atmospheric testing taken in by people up until the year 2000 would cause 430,000 cancer deaths, some of which had already occurred by the time the results were published. The study predicted that roughly 2.4 million people could eventually die from cancer as a result of atmospheric testing. Temperature perturbations are calculated to be in the tens of degrees Celsius, and in a fully interactive model, the atmospheric lifetime of the particulate matter is enhanced so that the duration of nuclear winter would be at least a few months. These qualitative conclusions are also important in helping assessing other environmental stresses associated with the atmosphere. All ionizing radiation is carcinogenic, but some tumor types are more readily generated than others. A prevalent type is a leukemia. These include the distribution and transformation of toxic chemicals released from chemical plants and produced in nuclear fires. A multitude of toxic pollutants would be produced by the pyrolysis and partial combustion of chemicals, petroleum products, and synthetic materials stored in strategic, industrial, and urban areas. A special feature of a nuclear explosion is the emission of nuclear radiation, which may be separated into initial radiation and residual radiation. Initial radiation, also known as prompt radiation, consists of gamma rays and neutrons produced within a minute of the detonation. Gamma rays and neutrons can produce harmful effects in living organisms, a hazard that persists over considerable distances because of their ability to penetrate most structures. Though their energy is only about 3% of the total released in a nuclear explosion, they can cause a considerable proportion of the casualties. The 2000 report of the United Nations Scientific Committee on the Effects of Atomic Radiation to the General Assembly states that the main man-made contribution to the exposure of the world's population to radiation has come from the testing of nuclear weapons in the atmosphere from 1945 to 1980. Each nuclear test resulted in the unrestrained release into the environment of substantial quantities of radioactive materials, which were widely dispersed in the atmosphere and deposited everywhere on the Earth's surface. Acute radiation syndrome (ARS) may develop in those who are exposed to radiation levels of 50 to 100 rad, depending on the type of radiation and the individual. Symptoms of ARS include nausea, vomiting, diarrhea, and reduced blood cell counts. Radiation, especially beta radiation, can cause skin burns and localized injury. Fatalities begin to appear at exposures of 125 rad and at doses between 300 to 400 rad. About half of those exposed will die without supportive treatment. At very high doses, greater than 1000 rad, people can die within hours or days due to effects on the central nervous system. Radiation exposure inhibits stem cell growth. For those who die within weeks to months, death is usually caused by damage to the gastrointestinal lining and to the bone marrow, where stem cell growth is crucial. Fetuses are more sensitive to radiation. Effects may include growth retardation, malformations, or impaired brain function. The very existence of nuclear weapons is a threat to future generations and indeed to the survival of humanity. What's more, given the current regional and international tensions, the risk of nuclear weapons being used is the highest it's been since the Cold War. The terms can either refer to radiation from a radioactive source, the radiation dose absorbed by a person, or the risk that a person will suffer health effects from exposure to radiation. When a person is exposed to radiation, energy is deposited in the body's tissues. The nuclear-armed states are modernizing their arsenals, and their command and control systems are becoming more vulnerable to cyber attacks. There is plenty of cause for alarm about the danger we all face. What would humanitarian organizations do in the event of a nuclear attack? The hard truth is that no state or organization could deal with the catastrophic consequences of a nuclear bomb. There are two aspects to blast: the shock wave and winds. The shock wave is a wall of compressed air traveling outward from the explosion at speeds above the speed of sound, dissipating as it goes. It crushes objects in its path. The wind follows behind the shock wave, blowing over objects in its path. Houses can withstand peak overpressures of approximately 5 pounds per square inch (psi), whereas hardened military structures can withstand peak overpressures above 1000 psi. Blast waves are lethal to humans primarily because the wind picks up objects that become lethal projectiles. The lethal range for winds against humans is roughly equivalent to the range of the 5 psi shock wave. Scientists use different terms when measuring radiation. The Curie symbol Ci is a unit of radioactivity. It has largely been replaced by the becquerel, which is the unit of radioactivity. 1 becquerel is defined as the number of atoms that decay per second in a sample. The Curie unit is named after Marie and Pierre Curie, who conducted pioneering research on radiation. A person's biological risk, that is, the risk that a person will suffer health effects from exposure to radiation, is measured using the conventional unit REM or the SI unit SV. The nuclear power plant accident, a nuclear explosion, or a dirty bomb are examples of radiation emergencies. If something like this happens, you may be asked to get inside a building and take shelter for a period of time instead of leaving. The walls of your home can block much of the harmful radiation. Cover your mouth and nose with a mask, cloth, or towel if you must be outside and cannot get inside immediately. This can help reduce the amount of radioactive material. If you're in a car, bus, or other vehicle during a radiation emergency, get inside a building right away. Cars don't provide good protection from radioactive material. Carefully remove your outer layer of clothing before entering the building, if you can. Radioactive material can settle on your clothing and your body like dust or mud. Once inside, wash the parts of your body that were uncovered when you were outside. Then put on clean clothing if you can. If you've loved ones in schools, daycares, hospitals, nursing homes, or other places during a radiation emergency, stay where you are. Going outside to get loved ones could expose you and them to dangerous levels of radiation. Children and adults in schools, daycares, hospitals, nursing homes, or other places will be instructed to stay inside until emergency responders know that it's safe to evacuate. The terms can either refer to radiation from a radioactive source, the radiation dose absorbed by a person, or the risk that a person will suffer health effects from exposure to radiation. When a person is exposed to radiation, energy is deposited in the body's tissues. The amount of energy deposited per unit of weight of human tissue is called the absorbed dose. This is measured using the rad or the SI GY. Let us know your opinion in the comment section down below. This was all for today. Hope you liked the video. Don't forget to subscribe to our YouTube channel. Please click on the next video clip to watch for more health info. Thank you very much.